Okay, so today we're talking about ratios, proportions, rates, and unit rates. I'm going to start with a few definitions. So a ratio compares two values. Compares two values. And then there's some examples. A ratio of blue-eyed students to the entire class is 11 to 27. And that would be 11 blue-eyed students to 27 students in the whole class. So you have to know blue-eyed was said first, and then entire class, so blue-eyes is listed first, and then the entire class. Or the ratio of milk to oatmeal in the cereal is 1 to 3/4. So that would be milk is 1, cereal is 3/4. Or the ratio of tea to lemonade in an Arnold Palmer drink is 5 to 2, means 5 parts tea to 2 parts lemonade. All right, so ratios that are written with the 2 or the colon can also be written as fractions. It is important, though, to remember to always label, and that's extremely important. Label your values with the appropriate units. So, for example, the first ratio above would be, so right there, cross out, I think the ratio again, accidentally, that's a typo. All right, would be, so we could write it, blue eyes is labeled, so the numerator would be 11. And then the whole class would be the denominator, which would be 27. Or, the second ratio, we're talking about milk to oatmeal. So the ratio is 1. And they don't say if it's cups or not, so they don't give the units, but in a ratio they don't really have to. So that's going to be 1 part milk to 3/4 of oatmeal. Probably cups is the way we would think of it, but they don't have it labeled, so it doesn't matter. But you could use this as a ratio to get the cups or to get the liters or whatever you need. If you need to make the recipe for more people, then you can use that same ratio. Then the ratio of tea to lemonade for Arnold Palmer is 5 to 2, so that'd be 5 parts of tea to 2 parts of lemonade, and those parts would have to be the same there. Could be cups, pints, liters, however you'd want to do that, and you will get the same taste. Okay, so a rate then gets a little more specific. It's really the same thing as a ratio, but it compares two quantities, Quantities, measured in different units. So in a rate, we want to make sure we include the units, whether it be cups, liters, same thing on that one. All right, so some common rates that we use every day are called unit rates, which are special because they have a denominator that is equal to 1, right? Hopefully you guessed that. All right, so one example would be 55 miles per hour. So that means you could travel 55 miles in 1 hour. That's a unit rate. Normally, you see it written MPH, but MPH means miles per, that's the fraction bar, and then the denominator, it just says hour, so that's assumed to be 1 hour. All right, so our next example is talking about unit rates and unit rates, but I want you to take your heart rate. So what I'd like for you to do is, as soon as I show you how to do this, pause the video and find your pulse. And I would like you to take your pulse by taking your wrist below the thumb and put your pointer finger and the next finger, don't use your thumb to find it, but right about there I can feel my pulse pulsing. And so what I'd like for you to do is pause the video and try to find your pulse. And then when you turn it back on, I'm going to time for 10 seconds. And I want you to count how many times your heart beats in those 10 seconds. So pause the video and find your heart rate, and then we'll come back on. Okay, so when you find your heart rate, I'm going to start. Ready, go. Stop. Okay, so however many beats you had in 10 seconds, you're going to write it in there. And I'm just going to do an example and say that we had 9 beats in 10 seconds, but you use whatever your heart rate is. So what a nurse would do is they would take your heart rate and they would use either 10 or 15 seconds, and then they would convert it to beats per minute. So on the paper that they're going to fill in your heart rate for on your medical records, you're gonna see BPM for beats per minute, and they're gonna fill in the time. But they've only done it for 10 seconds, so they actually need it for 60 seconds, which is the same thing as a minute. So what you would have to do to get a equivalent fraction or an equivalent ratio, you would multiply the denominator by 6 to get 60 seconds. So you also have to multiply the numerator by 6 and get 54 beats per second. You would fill in whatever you got there. And that would be the exact same thing, because 60 seconds means 1 minute, so it'd be 54 beats per minute. And so the nurse would just fill in your chart with 54 BPM. So that's another unit rate you see in everyday life. And then just for the fun of it, if we want to go to how many beats that would be in an hour, you would have to multiply your minutes times 60, because 60 minutes is the same thing as an hour. So if we multiply the numerator by 60, we would be taking 60 times 50, which would be, I'm just doing this mental math, 60 times 50 would be 3,000. And then 60 times 4 would be 240. So if we had those in our head, that's going to be 3,240 beats in 1 hour. And you would put in whatever you got there. So these rates, or ratios, are all equal, so they're said to be proportional. And we'll come back and look at proportions. They're going to play a huge role in everything we do up until your CFA on next Friday. All right, so let's go on then and just do some examples. So if you want to pause the video and write each of these as a unit rate and then come back and check your work, that would be great. Okay, so welcome back. So driving a car 60 miles per hour, you would say 60 miles, you got to label it, per 1 hour. Getting paid $12 per hour would be $12 per 1 hour. AT&T charges, that would be 10 cents, but that's how you write it. So 10 hundredths of a dollar per 1 minute. That's 10 cents per minute. Okay, so now if you'll turn your paper over. Oops. I have to actually put a bit of paper in here. All right, so now we're looking at what a proportion is. So a proportion is two ratios or rates that are equal to each other. And this is a very powerful thing, and it's going to help us be able to calculate a lot of different things. So we're going to look at this first example. So to make 4 large pizzas, time out a minute. Let's see if yeah. Okay, before we do this, I want to talk about when you have proportions or equal ratios. I'm going to take the ratio 2 to 3, and I'm going to set it equal to something else that means 2 to 3. I'm going to multiply by 5 over 5 and make it 10 over 15. Okay, what you can do there is you can say, okay, 2/3 is equal to 10 over 15. And if the one fraction or one ratio is equal to another fraction, or they're proportional, then that means their cross products are equal. So when we cross multiply, if we take 2 times 15, that should equal 3 times 10. And it does, because we get 30 here and 30 underneath 2 times 15. So their cross products are equal. So this is going to be very helpful to us. And we'll actually, in this class, use the algebra, because we'll have one of these that's missing, and we'll have to find the other. And we'll do that with percents and unit rates and any kind of ratios. So this will work. You could take any fractions you want, cross multiply them, and you will get equivalent cross products. There's a reason why, and at the end I'll talk about that. And if you come in tomorrow and it's going to be a little exit ticket in order to get your assignment, to start working on your assignment, you're going to have to tell me why, when you cross multiply, cross products are equal. And I'll talk about that at the very end. Okay, so let's do these two examples, and then you can you'll be done. You'll just have to listen to that. Okay, so to make 4 large pizzas, Paul needs 14 cups of pepperonis. How much pepperoni does Paul need for 1 large pizza? So my suggestion is always underline the important information. So 4 large pizzas, he needs 14 cups of pepperoni. And our question is, how much pepperoni does Paul need for 1 large pizza? So we don't know how much pepperoni, so I'm going to, right here, this how much pepperoni, I'm going to put P. But we know it's going to be for 1 pizza. So we're going to say P over 1 pizza. So there's our unit rate. And then P here stands for pepperoni. And then we've got a given ratio, and these would have to be proportional if we're going to cut the recipe and just do 1 large pizza instead of 4 large pizzas. So when we make the ratio, the denominator is going to have to match up to the denominator over here in our unit rate. So we have 4 large pizzas, so we'll put 4 pizzas and put P-I-Z. I'm just going to put P-I-Z for pizza. And then we know how many cups of pepperoni. How much pepperoni, we're going to say P cups, because it does say over there cups. So we'll say cups. There's 14 cups of pepperoni. So in order to solve this, of course, we can just say, well, what would I do to 4 to get 1? I can divide by 4, and then I could divide by 4 here and figure it out. Or we could cross multiply. So I'm just going to cross multiply here so we get used to doing that. So we're going to take 14 times 1, which is 14. And then we're going to take 4 times P, and we write that 4P. We always put the coefficient in front. The number goes in front of the variable. And so now to solve for P, we've already solved equations in a one-step equation. You just divide by 4, and we know we have to do both sides because it's equivalent or balanced. And when you divide 4 by 4, we did that so we could get 1P, and 1 times P by the multiplicative identity is just P. So P is equal to how many cups? Well, let's say 14 divided by 4, that's going to go 3 times. 3 times 4 is 12. So I have 2 fourths left over. So that would be 3 1/2 cups of pepperoni.